start the recording over here. So I was planning to go through all the parts that we were behind and keep going, so we can actually catch up with days that I was sick, but I had few calls from students that had concerns and they wanted to see how they want to catch up and learn and stuff like that. So I had in OOP345, did I have a session about how to use ChatGPT in this class? No. So I had this session with my 244 students in Part 12, so I'm going to have this thing over here and kind of demo and record it so people see how you're supposed to use something like ChatGPT to be able to actually learn from. We are in the age of AI, so it's stupid for me to pretend that people are not going to use AI. So at least we got to see how we can actually use it properly. So I'm going to create a new profile in Chrome for myself here. The reason I'm doing this is that, whoa, that's big. The reason that I'm doing this is to be able to actually create an account on ChatGPT to show you exactly how it's done. So I have an email that I created for this demo at fardat.com. So I'm going to sign in to my Gmail account with that, which is this. So it's a new profile that I created. Now I'm going to go to my Gmail account. So I have a Gmail account now, and my email is in front of me. And let's start. So what I will do in here is, what I do here is I'm going to start with ChatGPT to show you how it's supposed to be done. So action required, what action? Signed in. That's okay, let it be. So I'm going to go to ChatGPT in here, ChatGPT, and chatgpt.com. There are lots of sponsored stuff. Be careful about those things. When you put ChatGPT, things come up that are not ChatGPT. Like, careful. They all use the OpenAI, so interface is identical. Careful about it. Make sure it's actually ChatGPT or Grok. Grok is very, very intelligent too. Some people have choose that one, but choose whatever you want. If you have around $80 to spare, I strongly suggest, at least for the rest of the semester, get the paid version. So it actually uses GPT-5 and it's going to be much more smart, okay? So it would be a good idea to do that. So I'm gonna sign up for free, I'm gonna say, and I'm gonna use continue with Google because I just used the Fred Soleil thingy. So I'm gonna use that and continue. So I created an account. Authenticate, you have an account because it's been deleted or deactivated. There's an error. Oh shoot, I deactivated one. Now I want to reactivate. So let me see if I can actually go with the email. Demo at fardat.com. Continue. Or maybe I can sign in. Problem is that if I sign in, 20. Okay, let me see if what was that? Darn it. What can I use? Let me see if I can use something else. I'm going to use another account. Let me see. Give me 2 seconds to create a new profile in here. So let's. I thought if I just delete and reactivate my account, it works, but it didn't accept. So I'm deleting that, and I'm going to add another one. Okay. I create another one. Let's see if it works. So again, I'm going to go to, actually I have to go to email first. Let me bring it over here. I don't want to see my emails. All right. Okay, now I'm going to bring this one over here. Now I'm going to go to ChatGPT with this one. So ChatGPT one more time. ChatGPT.com, fine. Sign up for free. Continue with Google. That's that one. Continue. I'm going to say over a full name. I'm going to put over here Fred Soleil. And say I was born at, I don't know, 03/12/2003. Okay, so I'm a student type of a thing, let's say. Okay, so create that. So the account is created now. So the very first thing that you're going to do when you get, what brings you up over here, I'm at school, so next. And what you want to do, I want to learn and study. Continue. So nice to meet you. It creates quick tour and stuff. I don't want to take a tour, skip the tour. You can take the tour if you want. Continue. I'm going to come over here. So let's close everything over here. The very first thing you need to do is to go to settings of you and talk about yourself and go to personalization and go to custom instructions over here. So the very first thing you're going to do, actually I wrote the custom the proper things that you need to say to ChatGPT so it actually behaves properly for you. I'm going to open it up and copy it and paste it. So, and I called that thing learn2fish.md. So, it's going to my other one. Let me just open the other one because this one doesn't have the extensions installed. Let me open that one. Okay, that's better. And now let me open it one more time. There you go. So these are the things that you're going to actually write over this. So the very first thing you're going to write over here is to saying that I am a student of Seneca College. Oh, sorry, Seneca Polytechnic. Polytechnic at Polytechnic. Is it wrong? Polytechnic. How did I write it? Anyways, Seneca Polytechnic in Ontario, Canada. Ontario, Canada. Today I'm off my game. Ontario, Canada, and I want to study using using your capabilities. Okay? I save it. Other things that you want to say, nickname you want it to call you or something like that. So it's saved, and I'm going to close it and get out. Then you're going to go to projects. Now, I don't know what you want to study, but let's say this is the one that we want to do C++ with. So I'm going to create a project over here, and in that project name, I'm going to say learning to program C++, okay? Or learning C++. Not only program, but everything, okay? So I'll create a project. That the project is created. This is where the important parts come in. So you go to the project and you're going to add instructions. And the instructions that I'm adding are the following. Take a look. First of all, use MD file for it, MD format to put the instructions that you want, because GPT understands it perfectly. This is what I'm going to do. I'm going to just put over here these information. And I'm going to show it to you in a second. Copy. And these are the instructions. I am learning programming, and I want you to help me understand and practice, not just give me solutions. While tutoring me, follow these rules. 1, explain the concept first. 2, then ask me to write the code myself. 3, when I show you my code, review it, point out mistakes, misunderstanding, or logic issues, but do not give me the correct code. Let me fix my code on my own based on your feedback. We repeat this until my code works correctly. Only after my version works, show me a more efficient or professional version of the same solution for comparison and improvement. Important, do not give me answers directly. Teach me to think, debug, and solve problems on my own. Reference materials, if needed, are follows. So I gave the URL for the site that we have, the advanced OOP thingy. Okay? Then you save. Okay? Now I want to study. So what I will do, I will first see what I want to study. So let's find something over here as an example. So I'm going to try and find, I'm actually going to the notes. So Seneca 345 notes. So what should we do? Say we want to go algorithms. Okay? So I'm going to pick that one up, and I'm going to say copy, and I'm going to go over here. I want to learn algorithms in C++. These are the notes to study from. Let's start. These are start, okay? And I'm going to paste the things, okay? And I'm going to say, let's start. Okay? Now, if you use GPT-5, then it's going to be much faster and better working thing. Now, so let's start. Now it's going to teach you everything about STL. So read these things properly, go through it one by one, and let it go. And you see it's very slow. It's not going to be like that when you are using the paid version. Okay? You see over here, before, what do you think of std-find? Will return if the elements is not found in a thing, okay? So what do I think it will find? I'm going to say, I think it will find false. It will find, and remember, you can do this. You don't have to type. So you can simply click over here, and let me choose 1, 2, 3. Which one is this? 1, 2, 3. It's hearing me, so I'm going to use this. I think it will return true when something is found or false if it's not. And send it. It's very common first thought. So it leads you through the things. It really teaches you. And then it's going to tell you exactly what's going on. And it gives you segments of code to understand and tells you how things are supposed to be done. Then it's going to say, write a small program that creates a vector of integers with few numbers, ask for a user to do this and that, and so on and so forth. Then you write that code. Write it with mistake. Write it. Do not just go to your, Go to your code editor and write it without compilation. This will help you with IntelliSense and everything. And then paste it over there. It's going to go through your code and check how everything is done. So what is it asking me to do? Create a vector with few numbers, ask user for a number to search, uses to check the number exists, print found or not found accordingly. Okay? So really write the code any way you think it's right. Write garbage, it does not matter. It will go through it and step by step teaches you how to program. You do this, and believe me, you're going to pass this subject with an A+. You ask it to write you the code to understand how it works, it's not going to work. The results are going to, you have received your midterm. You know how you program. So this is what I want to ask you to do. Please use ChatGPT like this. I'm not saying don't come and ask me. I am at your service. I said that at the beginning of the semester. I said anytime you have a problem, book an appointment, I'll tutor you. 3 people did. So this is at fingertips. There is no judgment. It doesn't care who you are. Just create an account. And if you actually register for it, pay the $80 for 2 months. It's something like, I think it's $30 US, I think, per year. It's something like that. Don't quote me on that. I don't know what exact price is, but I know it's less than $100. Not in your lifetime. You can pay somebody $100 for 2 months to get you through things. Now, another thing that I want to tell you over here is this. So you are doing here, okay? And it actually answered you this, right? Now you come back over here. Let me see what was at the beginning it said. So right off the bat, let's say I say let's start, okay? You can literally edit this, or I'm going to come over here. I'm going to come over here and edit this one, all right? So I'm going to say I think it will return true or false if it's not. Also, please note that I am not very, I note that I don't know containers very well. Okay? And then send. So it's going to regenerate the thing that it did based on what you were saying. Or if you see it's actually telling you at the top over here, it's going to use this and that, then you can always go, if you see over here it tells you something that you don't understand, you can say, explain this knowing that I don't know this. It's going to regenerate everything based on that. Now you see what happened? It answered you like that. Now it's going to say understanding containers, teaches that one to you. So there's no excuse that it uses stuff that I don't understand. Anything you think it won't, you simply go back, edit your response, and it's going to come back. And it's going to, first of all, there's no limit if you actually pay for it. But it's a rescue boat that I'm giving to you. So if you really want to learn, that's the way it's done. And it's not only for this. You can study anything with this, even English or anything. Just use the same way, tell it to teach you and not give you the answer. Believe me, it's going to work. Okay? That's it. Anybody have any questions on this? And it says upgrade for free. What is that? Special offer source here, business. Your current plan, limited file uploads, limited slower, yada yada. Oh, so you can get the business for a month with this. Get it for a month and cancel it afterwards and just go get the thing. So you know how intelligent. So for a month, get this thing as business. So it makes you, like, it becomes extremely fast and very resourceful. Go use it and then, anyways. So that's that. And the good thing is that you stopped right now. You're studying this right now, let's say. Let's go back. You're at this point, and I say, okay, I don't have time. Doesn't matter. Just you go back over here. You can always continue that afterwards. One point that I give you, ChatGPT and all these AI, they have very bad memory. They have kind of dementia. So what happens is that if you are doing this learning thingies with algorithms, you're doing like that, you're doing algorithms. If you want to now switch and learn smart pointers, don't continue in this. Create a new chat and only deal with that. So one topic per chat. If the chat becomes too long, it will forget things from the top. So remember, keep your chats short. I don't know, maybe in business plan it's going to be better, but that's what it is. So these are the things that you need to know. And for every single class that you have, and anything that your database, anything you have, you can create a new project, give it the notes that you're supposed to give. And if you don't have access to notes, you can give it PDF files, you can copy and paste the content from a website. It will sort out through it very easily. Okay? So that's that. We good? All right. So, yeah. Let me stop this. So I'm going to close this one. I'm going to keep my oh, it is recording good. Okay, so I'm going to keep my profile for the next class to explain it to them. And that's that. Now we can start. Any questions about anything? Okay. I sent a message. Everybody's asking how much should I get to pass the subject. I sent a message on the 345 team that we all have, exactly how to calculate what mark you're supposed to get. You have all the three on your thing, right? The midterm. Okay. Also, again, double check your concept, because concept and debugging section, you can get lots of extra marks if you have things partially done correctly. Take a look at them and see if there is anything, like if you put a space or something extra in the walkthrough and it doesn't give you the answer, you can still get marks. Book an appointment with me and I'll fix it for you. All right. So now that is done, I'm going to pause recording and resume recording over here. Okay, so let's talk about files over here. So what I'm going to do in here, I'm going to add existing items in here, and I'm going to go through and bring the employee in that I created and add it to the program. Take a look at the employee that we have. This is something that we have created last time, very close to what we created last time. So I have an employee, it has a salary, it has an employee number, it's a name that has 52 characters. This class doesn't have resources. It doesn't need rule of 5, doesn't need anything like that. So everything's contained within, so it is as what it is as you see. So for this one, I created a less than operator, an OStream print to print, and a read that reads from iStream, okay? And I overloaded the iStream and OStream for what we have over there. So very simple and straightforward. Looking at, let me just close this not to get confused. Looking at the implementation for it, it's pretty straightforward. For the constructor, I am setting whatever that's supposed to be set, as you see. So essentially, I did a string copy like this. I was hot-headed at the time, probably I did that. So this is literally a string copy. I didn't want to include anything, probably I did that. Then I have an operator less than that compares two strings. So this is a string compare. You have seen this code. I had it over there. You know exactly what it is. So essentially compares the two names and says which one is bigger than the other one. Then I have a print that prints it, and I have a read that reads exactly like this. So it, as you see over here, it first get lines up to whatchamacallit, comma. Then it reads an integer, then it reads a double and puts everything inside the thing. And I don't have any error checking over here. Why? Because the mechanism that iStream works already satisfies that if something goes wrong, iStream is going to fail, and I know exactly I couldn't read the thing. So it is possible to just to leave it. They can always test iStream afterwards to see if it failed or not. And overloading the OStream and iStream, that's a 244 thing you don't need to explain. So we know exactly what we have here. Now, what I'm going to bring in is this. So I have main written like that. As you see, I create the iStream, and I'm going to go one by one, read from the file, put it in the employee, and display them one by one. We okay with that? Right? Because it reads from the thing over and over, it's going to read from the file, and everything's going to be fine. And then what show record does demonstrates why texts are not efficient. Now, let me first run this, make sure it works. Oh, builders. No, what are the builders? Let me see what's going on here. Compile. Compile. Okay. Control F5. What does it say? Oh. I'm compiling the wrong file. My apologies. Set as startup. I was compiling the one that had nothing in it. Okay. My apologies. I was compiling a different thing. I'm like, what the heck? Okay. As you see, the program is working like this. First, I'm printing everything out in that loop. So one by one, I'm reading and I'm showing them. And then I'm going to say show record 10. So you know that this show record 10 is actually is showing the 10th record of the file. This is, there you go, 10, Chip Davis, you see that? And if I go more, it's going to say the file was reached. Okay? So now take a look at show record. So this looks random to me, which means it looks like I can do this. So as you see, it is actually going back and forth in the file and printing everything from everywhere. Looks very awesome. But if I look behind the scene and see how it's done, you'll see that something is very fishy. Look at this. Look how my show record works. I'm receiving an IF stream. First, I'm clearing everything, okay? Then I'm fseek G. It means for reading, go to the beginning of the file. It goes to the beginning of the file, which means anytime this function is called, reading goes back to the beginning. It always starts from the beginning. Then, and clears the file in case file fail, is in failure state. It brings it back. Seek G, again, G is for getting. It means for receiving. So reading will go to the beginning. Then it starts reading one by one until it reaches to the row. So when I want the 15th one, it has to read 0, 1, 2, 3, and it keeps going until it reaches to the 15th record. Now, if it reaches to the 15th record, F is not in a failure state. Therefore, it's good. It's going to see out, show it, and come out. But if it hits the end of the file, it's going to say file reached to the end. So when I showed the 10th one first, it started from 0, read everything to 10. The second one got back to the beginning, read everything to the 5th, and then gets 0, and then jump to the end. Awful. We don't want this. What is the solution for this? The solution for this is something like this. Set as start a project. Let me go to my cheat sheet and bring the program for you. Where is it? All right. Okay, just a second. Where is this? There we go. Okay, and now, all right, so take a look at this. For this, I need to bring something else up. Yada, yada, yada. That's better. Okay. So let's take a look at this. I am writing in a file. I'm going to say open files for writing called numsbin. It's a file that is supposed to hold binary values, not text, which means not human readable. Then I create a vector of 5 doubles over there, as you see. Okay? Now I'm going to say start from the beginning to the end. Now, what write does is this. Write receives a pointer to a character, constant character pointer at the beginning, and a size. From that address, reads that many characters. So what I'm doing over here is this. I am sending the address of the double as a character, and I'm going to say the size is V, which is 8. Therefore, it starts from the beginning of each double in memory and dumps that 8 character into a file. And when I run this program, obviously, when it runs, did it run? Yeah, when it runs, you will see that I actually have numsbin. And if you look at numsbin, that's what you have in there. Garbage. Like you can't even see anything in here. Can I? It doesn't allow me to zoom in to show you. But as you see, there are just some bytes in memory. If you look at it, the number of bytes over here is exactly the number of the elements of the vector multiplied by 8. Exactly that much. Okay? Now that I have that known, so that's how I write binary in a file. And when you look at the file doesn't show any content because it's all binary values. So then what I can do over here is actually read from it. Look at this. So now I create one double, not a vector. Then I'm going to say, now read is exactly like write. It receives a character pointer. Character is the smallest size of, it's a byte essentially, right? It receives a character pointer, not constant because it wants to read into it. Then it receives a size. So it says, tell me where, and I'm going to read these many bytes from the file and insert it in it. So essentially, the nums bin that I created as OF stream, now I'm creating it as IF stream. I am opening it, and I say, read from the file, if you can, read from the file, size of a double, and put it in this character address. What is that address? The double that I have up there. Therefore, my double will get recreated of its disassembly when it was written. So when it was being written into file, it got disassembled, and byte by byte were written in a thing. It does the exact opposite. Therefore, it gets reconstructed to the original value. So when I run this, the outcome is going to be exactly those values that I have written, but from a file. Are we okay with this? Please appreciate that the file that we had is all binary and it's not human readable. Okay? Now, what good does it do for us? The good thing is, now I can do stuff like this. I'm opening the file for read. Now I'm saying, go 0 bytes after end. What does it mean? It means go to the end. That's another overload for seek_g. Seek_g can accept an offset, which could be negative or positive, and from where. That from where at the end can be 3 different things. It is offset, which is either negative or positive. This could be iOS beginning, iOS current, or iOS end. So for example, wherever you're in file, you want to go 8 bytes back. You can say seek_g from current minus 8. It means go 8 bytes back. So literally, you can go back and forth in a file wherever you want. Now I'm saying go to the end of the file and go 0 bytes further, which means go stands at the end of the file. Now I'm going to say, tell me where you are. So tell tells you exactly which byte right now I'm standing at in the file, which is the end, right? I divide it by the number of doubles. That's going to tell me how many records I have in a file. So I don't need to count anymore how many records I have. All I need to do, jump to the end, get the size, divide it by the size of the record, and that's what I have. And a double is an 8, right? So that's the first thing I'm going to get. So when that thing runs, this is what I'm going to get. And let me make it a bit smaller. Okay. So you can see it back there, right? Yeah. So it starts, opens. Now it goes to the end. Now it tells me I have exactly 4 doubles in that file. Okay? Now I'm going to say seek G, size of double multiplied by 2. What does it mean? It means when you put only one argument, you are telling it where to go, not back and forth. So I'm saying from the beginning of the file, go to size of a double multiplied by 2. So it literally skips 2 double and stands right before the third double. Now I'm going to say read. And it reads it, and when I print, it's exactly the third one I have written over there. You see that? So you can literally jump anywhere you want in the file and read it. So I can now do this. Zero. And here I'm going to say iOS and I'm going to say, I think I have to go static cast to, what was the stream pose, right? No, seek G, stream pose is the first, stream offset. Stream STD, stream offset minus size of double. Am I good? So I'm saying seek to minus size of double. When C++ wasn't that type safe, you could just write minus size of double. Now you have to actually cast it. So if you just do it like, maybe it does, even this doesn't work. We're going to find out. Maybe I have to say minus that. We'll find out. But anyways, I'm saying go to the end, come 1 double back, and now read. So I'm going to read first the third one. Then I'm going to read the first one. Then I'm going to read the last one. Okay? So running this one more time, see if it works. No, errors. What does it say? Minus operator applied to an unsigned type. Yeah. So probably I need to go here. Minus. Let's see if that works. If not, I have to say minus 1 multiply 2, I think. There we go. Okay. So now I'm going to come over here. Now it says the size is 4. Now it goes to the third one, displays the third one. Oh, I forgot to display. My apologies. Sorry. With all that excitement, I wrote everything, but Control C. So that's a read, Control V, and that's a read. Are we good? Yeah, I think we're good. So we'll start. Four. So it reads that one. Now it reads the first one. Now it reads the last one. And it took exactly 3 read times, as if you are reading the 3 first records. In the other one, I had to every time jump back, read the entire thing, assume if I had 1,000,000 records. If you run it this way, it's going to take literally the size of the time it gets for the first 3. With that one, you have to wait for 10 seconds to go through everything because it's on a hard drive. It's going to take time. Got it? So that's binary read and write. Save. Stop. Okay, so that's, see, I'm going to call it random access read. You can do the exact same thing with write. So what I could do, let me see if I can actually modify it very quickly over here. So instead of having IF stream, you could have had F stream, open it for read and write. It's going to take time. I'm not going to do that. Do it at home, practice it. Create an F stream, which means you're going to have I stream and O stream. Then open it for iOS in, iOS out, and binary. Okay? So, and then you can actually write everything, and you can actually write halfway through. Go overwrite the third record with absolutely no problem. Okay? Yeah, so that's that. One thing I have to mention, that is, it's a common mistake. I made that mistake, and I paid for it dearly. So, so with TLG, now I'm just going to show you the size of the file. So please take a look at it. So in here, I'm going to say if not file, I'm going to say cout. File in fail status. Okay? So take a look. When I run this program, it goes to the end, and it tells me that it's 32 bytes, right? And it says it doesn't say anything, so it is not in a bad state, right? And you know that it's only 32 bytes, right? See what I'm going to do. I'm going to say over here fseek file dot fseek g, not p. P is to write, G is to read. In here, I'm going to say 10,000. Sorry, fseek is C language, seekg, okay? Now I'm going to go Control C. And I'm going to run it. Take a look. You know it's 32 bytes for a fact. But when I run this, it's going to tell me 10,000. And still, the file is not in a failure state. Remember, seeking will not fail. It's reading that puts the file in a failure state. So when you are telling seekg 10,000, you're telling to the file system that your next read is supposed to happen at position 10,000. It will not actually go to that position. But if I actually read now, is it saving them? Oh, binary access. Now I'm going to put the if statement again. And run it. Actually, let's put it over here. So now it says that. The first one didn't fail. Now I'll try to read. Now it is in a fail status. So remember, fail status is only when you read, not seek for reading or writing. Not seek P, not seek G. It will not put file in a failure state. Are we good? Are we okay with this? Okay. So that's that. I'm going to say, why I keep saying over here binary write? This is wrong. This was binary read. Okay, so fix that. Now in here I'm going to say D, seeking will not fail. Seeking will never fail. Just remember that, okay? All right. Now that we have this, it's 2:30. Let's go for a break and come back, and I'm going to prepare the next one. I'm going to pause recording over here and stop the recording. Okay, so let's continue. Where's the... All right, so now we're going to do a binary write using that employee thingy that we had. So as you see, I created an employee called B employee just to show that it's this binary employee that I want to write. I don't want the names to be confused. So it's the exact same thing that we had. As you see, I have an employee with all this stuff. We just had it, and we could print it and all the good stuff. So that's the employee that we had. Now in my program, that's what I'm doing. I'm creating a vector of employees. And simply I'm going to go through every single one of them and write it in bEmployee.bin. Easy, right? So what I'm doing, I'm saying write, and I'm going to constant character size of employee. So essentially, it goes through every element of the vector over here. One by one, it dumps these values in it. Remember, a class is its attributes. The methods of a class has nothing to do with its size. Its method of a class is like the way we think. If I have a PhD or I don't have any educations, my weight is not going to change, right? It's the exact same thing. So no matter how many functions a class has, it has nothing to do with it. So I'm just going to dump those values right in a file. And running this program would essentially create this. And what you have here is essentially all the employee records that I have. You could kind of see Carl Nelson over there. You can see Charles Montgomery, Burns, and you can see all the names that are there, but it's not quite right, okay? The difference over here with writing a text is that it's going to take a bit more space because it literally dumps everything that you have in there into a file. But the good thing about it is that now all the records have the same size. So I can do stuff like this now. What I can do is this. So this is going to be, where is it? Close it. I'm going to say, we don't need this. I'm going to call it, let me delete that. composite binary write. Okay? And let's see what I'm going to do now. I'm going to do this now. To see how easy it's going to make it. Okay? So I'm saying open a file, employee.bin for binary. Create an iStream iterator of type employee, that is II, and assign it to file. Then I'm going to say another iStream employee, EOS, that is essentially end of stream. It's blank. Okay? Then I'm going to say create a vector of employees. First iterator is the II, that's the beginning of the file. Last one is EOS. That's essentially how to initialize a vector. So automatically through that iterator, it's going to go through the file, automatically read them one by one and put it in the vector. I don't need to do anything. That's how algorithms work. Then I'm going to say, show them one by one because I overloaded the cout thingy to show them, right? Then I'm going to say, pass employee beginning, EMP that I just read, and employee end to sort. So sort is going to start sorting it, but sort needs the less than operator. Because I overloaded it, it's going to call it. Then it's going to sort all the employees and print them all out. As simple as that. So it's just a demo. Of course, I could have, instead of doing that, I could have created a vector and I could read one by one. I could back insert into it one by one and add everything to it. All those things I could do. So there's no problem with that. You know exactly how it's done. There's no problem with that. But like this, you can see that using the algorithms and the containers and vectors and all the things that we learned from STL, how short a program is going to be. If I told you, write a program that reads all the binary information from a file, list them, and then sort them, and then print them, you know how long it would have taken to write the whole code for it? Now it's what, in 20 lines? So now if I run this program, this is how it's going to work. So essentially, oops, went to the wrong window. It's going to open the file. It's going to set the first iterator to the beginning of the file, set the last iterator to nothing, which essentially means the end. Then I'm going to say start from the beginning, go to the end, and create the vector. Done. Everything is read. Now, one by one, go through it and print everything. You see, everything is read from the file now. Then, now that everything is printed, I'm going to say, start from the beginning of the vector and to the end, sort it. Why it can sort? Because I overloaded this. It can compare the two. Or I could just say sort and pass a lambda expression that compares the two employees somehow. So this is going to sort it and then show it again. Okay? Now what I want you to do, go home and change these two for loops to for each algorithm. See if you can do it. It should take 3 seconds. I'm not going to do it. Go try it, because that's something that I'm going to ask in a test. I'm going to give you that, and I'm going to say, convert that conventional for loop to a for each algorithm. So make that algorithm do this. See if you can do it. It shouldn't be difficult. Okay, so yeah, and that's that. Everything's printed. So down to this point, everything is fantastic. We have all the stuff that we need with for the binary file writing and everything like that. But wait a minute. what if the file that I have, the record that I have, does not contain everything that I need, that I have in it. It does it dynamically. What happens if I write this as a binary in a file? It's going to write the salary, it's going to write an employee number, then it's just going to write an address, an 8-byte address that I have. That at the moment when the program is running, the name of the employee is in it. Then I'm going to turn off the computer. Come 3 days later, load it. It's going to load the exact same address that the computer had 3 days ago in memory. Is the name there? No. So for something like this, first of all, I have all the constructors, this rule of 5 applied to it and all the good stuff, but also, I need to write, because like you do for move constructors and copy constructors, you not only do shallow copy, but you do deep copy. I need to do the exact same thing for read and write in a file. So essentially, I'm not going to do a read write with iStream and OStream anymore. It is literally OFStream. And I'm going to say I need 2 of them. OFStream and FS. So OFStream is for the employee, and FStream are for names. So what I will do when I actually save the employee, let me show you. We don't have let me see if this works. Give me a second. I want to see if I can actually use this. It says annotate. So can I? Who can? Okay. Oh, I'm trying. This is the first time I'm using this, people, so bear with me. I'm going to say it like this. Okay. Oh, it does it. Okay. So this is my employee. Okay. And I have 2 files. So one file will hold all the employees in it. Okay. And I write that employee right into it. So when I write the file, I write the employee in here, right? Now I want to write the name. So this is the employee, and the name of the employee is there a place that I can choose a color? Sure. And the name of the employee is here, outside, somewhere, right? Now I wrote the employee over here. I want to write the name, and this is the file that I have for the name. So I put the first name in it. So I copy the content of this and put it in a file. What is the address of the beginning of this? 0, right, in the file. And it has a length, correct? So I save those 2 things right after here. I'm going to save where the location of the name is in the file, and what is, so this one, and what is the size of the file, size of the name. And I'm going to just add it after that. There are 2 integers, right? I'm just going to save it right over there. So when I'm writing, I not only write the name, but also I have a second file, and I'm going to write it over there. So the next record, when comes in, so when the next employee is written in here, the next employee is written here, it's going to be written here. This is going to be the second employee that is written. And then the name of the employee is going to be written right over here. And right after this, I'm going to write where the employee was in the file and what, sorry, and what was the size of the employee. So when the second record, so every time I'm reading, first I'm going to read the employee and dump it in there. Obviously, name is going to be somewhere garbage, right? Then I'm going to say, okay, I know exactly where to start reading the name and exactly how long I have to read. Because I know the size, I dynamically allocate it exactly like I'm doing copy constructor. Copy everything in it, put all the good stuff in it, and read it. So now I have two files. One is a dump of all names back to back, and I'm keeping the addresses for it. And the other one is going to be the employee. Still, the size is the same. It's not the size of the employee, it's a little bigger, but all the records have the same size. So how can I wipe everything up? Like this, view, clear options. Clear my annotation, clear all. There we go. And how can I stop this? Okay, good. So I can actually move this. I don't want this. So not very user friendly. How do I get rid of this? Okay, maybe I can turn it up from here. I don't know. It's there and I cannot move it, so let it be. Okay. Oh, it went away. Okay. All right. So let's take a look at the code that I have just told you. So let's come over here and take a look. So take a look at the right. Look at that. First, I have a string position. And I'm saying, hey, tell me where is the position in the name file at the moment. I need to know where I'm writing. Then I'm going to say, tell me what is the size of the name. I'm going to write the name to the exact, because name is already character, I don't need to cast it. I'm just going to say, write the name in that name file system and be done with it. Then I'm going to write the address of myself, which means I'm going to write the entire class. Then I'm going to write the name location and the name length, and I'm done. And every single time I want to read it, it's going to be the same thing. Therefore, when you're writing, the code will be something like this. So now I have the name and all the good stuff that I have, and I simply write every single one of them, and the result will be in dEmployee bin and dName bin. So when I run this 3 years later, please walk through it at home to see how it's done. And if I take a look at it now, I have employee bin that is all binary, nothing can be read. And when I look at the name bin, it's all the names back to back. And when I read it, it's going to be the same way. Please go home and write the read method for it, so you can read them one by one and sort it and see what happens. Okay? This one you cannot do with the vector thingy, because the read over here is different. Okay, you cannot just put it in a vector. Okay? You got to be careful. So read them one by one and see what happens. Any questions? All right. The next day you are coming in, we're going to talk about smart pointers next week. We did the chat GPT thingy. I think it was worth it to have that one. And still, so next week we're going to do smart pointers, and we're going to, I think, start doing parallel processing. Okay? So please use ChatGPT the way I told you, or Grok, and do exactly as I showed you, and it's going to help you a lot in future. Any questions? Suggestions? Objections? All right.